What's up, everybody? Welcome back. Moving on to the next question. This question is actually very similar to the previous video. It's just a little bit tougher. Process is going to be exactly the same though. So what value of m makes the line y equals mx plus 2x minus 13 tangent to y equals mx squared minus 2x squared minus mx minus 1? So both very weird looking functions, but nevertheless, this here is a line, and then this here is a quadratic. Because if m is just some kind of constant, let's say m was 6, we'd have 6x squared minus 2x squared, so this would actually simplify to 4x squared, right? So we'd have 4x squared minus 6x minus 1 if m was 6. Same thing here. If m was 6 here, this would be like 6x plus 2x, so these would simplify to 8x. Then we just have 8x minus 13, right? So we have a line and we have a quadratic. And we want the line to be tangent to that quadratic. So if you remember, if a line is tangent to a quadratic, it means there is one point of intersection. I mentioned that in the previous video and in a couple of videos before that. So, like the previous video, what you want to do is you want to make these two y values equal. So you want to follow the same process as if you're finding the points of intersection. So we would write out mx squared minus 2x squared minus mx minus 1 equals mx plus 2x minus 13. Then from here, what you want to do, bring everything over to one side. So I'm going to take all the expressions on the right side, bring them over to the left side. So we'll have mx squared minus 2x squared minus mx minus 1. And then we'll have minus mx minus 2x plus 13. And that's going to equal 0. Then from here, let's see if we could collect some like terms. So mx squared minus 2x squared, those are not really like terms. Minus mx, those actually simplify to minus 2mx. Then we'd have the minus 2x there. And then minus 1 plus 13, that gives us positive 12. And that's going to equal 0. And then from here, if you remember, you want to make this look like a quadratic. So you want to have an a value, a b value, and then a c value. So from here, from these two expressions, we could take out an x squared. So we'd have m minus 2 x squared. From these two, we could take out an x. So we'd have negative 2m minus 2x in front, and then the plus 12 is left as is. Right? So notice now it's in a quadratic format. Ax squared plus bx plus c equals 0. So the a value is m minus 2. The b value is negative 2m minus 2. Then the c value is 12. And then from here, we know that we want this quadratic to have one solution, because we want the line to be tangent to the quadratic, one point of intersection. So if a quadratic equation, which is what this is, right, ax squared plus bx plus c equals 0, if it has one solution, then that means that the discriminant b squared minus 4ac is equal to 0. Let's actually write it over here. Split this up a bit. So b squared minus 4ac, the discriminant, has to equal 0 if there's going to be one solution to a quadratic equation. So notice that we could just plug in for a, b, and c these expressions over there, and then we could solve for m. So the b value is negative 2m minus 2, so this would be negative 2m minus 2 squared minus 4. The a value is m minus 2. And the c value is 12. And that's going to equal 0. Right? And then from here, we could just solve for m. So we would expand everything. So negative 2m minus 2 times negative 2m minus 2. We would take those two brackets, FOIL them out. So negative 2m times negative 2m, that gives us positive 4m squared. Negative 2m times negative 2, that gives us positive 4m. Negative 2m times negative 2 again, that would give us positive 4m. And then negative 2 times negative 2 gives us positive 4. And then over here, 12 times negative 4 is negative 48. And we would distribute that into the bracket. That's going to equal 0. So from here, these are like terms, so we'll have 4m squared plus 8m plus 4, and then distribute this into the bracket, so we'll have negative 48m plus 96. That's going to equal 0. And then from here, collect more like terms, so 8m minus 48m, that would be minus 40m. And then we'd have plus 4 plus 96, so that would be plus 100, like that. Then we can, at this point, you could throw this into a quadratic formula if you like. I'm going to actually try to factor it. So I could take out a 4, m squared minus 10m plus 25 equals 0. And then this here factors as a perfect square trinomial, m minus 5 squared. So from here, we could tell the solution m is equal to 5. So there's actually one solution to this question. In the video before, we got two solutions because we had two factors. In this case, this is a perfect square trinomial, factors to m minus 5 squared. So m equals 5 is the solution to this problem. And you can actually check your answer. So you could plug in this m value of 5. So I'm not going to check it, but I'll show you how you can start it if you do want to check it. So if we plug in an m value of 5 here, we'll have 5x plus 2x, so we'll have 7x minus 13. That's the line. And then what's the quadratic going to be? We'll have 5x squared minus 2x squared, so that'd be 3x squared, minus mx, so minus 5x, minus 1. So you could check your answer by finding the point of intersection, or the points of intersection between this line and this quadratic. And when you do that, when you follow the same process we've been following, you should get one solution, right? There should be only one point of intersection because this line has to be tangent to this quadratic. So that's how you could check your answer if you have the time. But nevertheless, the m value that makes this line tangent to that quadratic is 5.